It's the protocol that's used for connecting to remote Linux servers.
An SSH backdoor.
Exploiting an individual.
Owning or maintaining any of these projects is horrifically stressful.
My ability to care has been fairly limited, mostly due to long-term mental health issues. Exploiting trust relationships with a project. Dennis, you are better off waiting until a new maintainer happens or fork yourself. Exploiting the trust relationships between a packaging system and a build system. A very minor modified version of this legitimate file, and then hoping that no one would notice. Someone noticed that timing difference.
Over to David.
CVE 2024 3094, how to create an SSH authentication backdoor. See what I did there? Rolls off the tongue. So what we're going to do is we're going to start at the end, because there's a lot to get through. But what I want to do is, I appreciate that there's a lot of context and it might get slightly lost. So I'm just going to go straight to the end of what happened at the end, and then we can go how we got there. Okay, so quite like this. Everyone's seen this one, slightly updated. You know, all modern digital infrastructure and a project some random person has backdoored. Right, so that's what we got. So what happened? There was a backdoor insertion. Malicious code was stealthily introduced into the XZ Utils software. Right? The backdoor allowed unauthorized remote access and control over affected systems. Attackers could execute commands compromising the security systems, and it was deeply, deeply integrated, which delayed the initial discovery of it. So we're going to go into a little bit of how they were able to do that. What is XZ Utils? Well, it's a library and a command line tool to handle the compression and decompression of XZ and LZMA archives. So you could think of it like zip utils or raw utils. Again, it's a utility specifically built that allows companies to be able to bring in with their libraries this function and then handle these formats. If you write software which interacts with standards, typically you would link to this project in your code. This toolset comes installed by default on most modern Linux distributions. So step 1, under pressure. Lacey Collin, maintainer of XZ Utils since 2010, all-round great contributor to open source software. I want to be clear, this person is a victim in all of this with everyone else. They've done excellent work in this field. They've contributed a lot of effort, a lot of their time, a lot of energy. And it's a shame in some ways that their name is being associated to what could have happened to anyone in the open source community. I just want to be clear on that one. Dear Tan, March 10, 2022. That's when this whole thing starts. Geotan made their first appearance on the project mailing list. So this is an open mailing list for the project, for where open source projects, people can come along, make contributions of code, be part of the discussion, involve themselves in this project. So they followed by a short code contribution, March 15th, 2022. Fast forward to April 19th, Geotan submits a patch via the mailing list. It is followed by Gigakumas making an appearance on the mailing list. There is pressure to merge the patch. So Giga says, patches spend years on this mailing list. There is no reason to think anything is coming soon. Over 1 month and no closer to being merged. Not a surprise. Suddenly, Dennis Enns sends a message to the mailing list, mocking Lacey. Why not pass on maintainership of XZ for C so you can give XZ for Java more attention? Or pass on XZ for Java to someone else to focus on XZ for C? Trying to maintain both means that neither are maintained well. Giga then bundles into the conversation supporting the narrative. Progress will not happen until there is a new maintainer. XZ for C with sparse commit log 2. Dennis, you are better off waiting until a new maintainer happens or fork yourself. Submitting patches here has no purpose these days. The current maintainer lost interest or doesn't care to maintain anymore. It is a sad to see for a repo like this. These accounts do not have featured any previous or future discussions. They appeared for this purpose only. In comes the hero. Step 2. Basic calling responds to various messaging highlighting Geotan's elevated involvement. I haven't lost interest, but my ability to care has been fairly limited, mostly due to long-term mental health issues, but also due to some other things. Recently, I've worked off list or off the mailing list a bit with Geotan on XZ Utils, and perhaps he will have a bigger role in the future. We'll see. It's also good to keep in mind that this is an unpaid hobby project. Next message. Geotan has helped me off list at XZ Utils and he might have a bigger role in the future, at least with XZ Utils. It is clear that my resources are too limited. Thus, the many emails waiting for replies. So something has to change in the long term. Step 3. The trapdoor is set. Geotan gains trust and becomes primary contact for XZ Utils on Google's OS Fuzz project, which we'll talk about a bit later. They also merge a testing infrastructure change, that's important, submitted by Hans Janssen. Super Hans shows little activity out of XZ. Right? Getting a bit technical, but I just want to highlight this because the timeline is important and we'll go into it a bit later. So the I function allows the selection of a different function to run when started based on conditions. So what this change does essentially is, in the moment of execution in the code, a decision can be made. So rather than going down a predefined static path that will always run, there's an element of dynamic execution. Now this got put in as a feature, as an improvement. But as you can probably tell already, it was the initial first step to allow a different path within the code to be executed. So what is Google OSS Fuzz project? If no one's familiar with the idea of like fuzzing or fuzzing software, or fuzzing logic or hardware, it really is just bombarding things with random data or randomness. It really is as simple as that. It's something where you take a port, a service, a piece of software that's used to taking this input, that input, and you send it all manner of garbage, all manner of things that are corrupt, out of whack, and just bombard it with randomness to see if anything sticks. You know, it's kind of the equivalent of if you're lock picking, sticking, you know, you're locking and just going, something's going to happen, and then maybe something does. It's run by Google, and it's there to allow open source projects to access these types of capabilities. So it's there to help enhance code's robustness and security, right? July 7th, 2023, we get Jan submitting a change request to disable ifunc testing on the OSS Fuzz project to reduce the chances of the automated tools detecting unusual or malicious behavior associated with the change. They claimed the compatibility issues with this particular switch, and due to ifunc having a history of causing issues, they allowed it. Again, it went from ifunc allows a static path to be managed by a dynamic path. Suddenly, if you've got something that's very sensitive to this, the fuzzing will instantly kick in and cause problems, or crash the program, or cause all these issues that aren't necessarily related. So it has been a policy for a number of projects to disable checking of that function, because it simply masks the real testing that happens behind it. It just crashes too soon. This got accepted. 1 becomes 2, step 4. Before we go in, just a little bit about open source projects and about the general hierarchy around how they work. So, open source project, have a code base on the internet, public code base. Everyone can see it. And at the very bottom, you have new users of your code base. They're there, they're looking there, they're downloading your code, they're reading your documentation, they're trying to use your code to do something on their machines. Experienced users may come back and go, I've had this issue when I'm running this code. Could someone help me? Or I've made this slight configuration change with the standard settings of the code. You know, here's a change set for that. Maybe you want to do something with it. Then there's contributors and developers who are more actively engaged in the project. They're not just users, they're there developing, contributing, moving the project forward, building new features. And at the very top, you have the maintainers. And the maintainers manage project direction and handle releases. January 19th, 2024, Year 10 is made a co-maintainer of the project. Trapdoor to backdoor. Step 5. So what's the objectives of the attacker? The objectives of the attacker is to include my malicious code in the project. It's also to have my malicious code execute alongside the real code on the computers it's installed on. My objective is do not raise any alarms while I'm executing and then profit. So we've talked about open source software. So let's talk about a little bit about open source security in depth. So what does a traditional attack look like on a code base like this? A traditional attack on a software code base generally involves directly going to the code, trying to obscure something in the actual main code base, the main primary files, and hiding it. But direct attacks on the code base often come to light because this is an open and transparent code base. As we said before, you've got new users, existing advanced users, contributors, developers. You have all these tiers of people interacting with your code base constantly, looking at the change sets that are going in. Any one of those would be able to potentially see any of these changes that would cause a problem. And then we also have a continuous integration process, which automates testing, security. So how do we do it? We attack the build system instead. What is a build system? So a build system automates the process of converting the source code files into an executable program by compiling, linking, and packaging the code. It takes the code that a project has, like the XZ Utils, puts it through a process, and out the end, you have a package that can be installed with a binary, right? It manages the dependencies, all the necessary libraries and tools. It also integrates with testing frameworks to automatically run tests against the build output. This is essential for identifying and fixing bugs early. Before you go to the build, you have to package. You have to provide a package to a build system. So let's think about the XZ packaging system. The XZ packaging system is really quite a standard thing. You have a version of your code. It's at a certain version, you're like, right, this is version 2. So what I'm going to do is I'm going to compress all of my code into a single file, give it an MD5 sum, present it or potentially send it to third parties, and they can then take it in, and we'll get to that after this. So their packaging system does that initial packaging, hosts it. Normally everything's fine. The packaging system for XZ is under the control of Year 10 as a maintainer. So we have our packaging system, and we have a build system, which is with the various distributions of Linux. So every distribution of Linux, they have their own build systems. What they do is they bring in all of these various package files, they bring them in, they're bringing them into their internal systems, and they build them. They go through they go through the testing process, they create binaries in their own formats, they get packaged and released internally, lots and lots of automation and escalation and movement of files. Happens all within every single distro has this, be it Arch Linux, Debian, Ubuntu, Red Hat, etc. Right. So one of the things it does is that it takes all of the various elements that are built within a project and pulls them all together into a single binary. And that's called linking. Right? Typically, these packages will be released and they'll go internally or they'll go out to the public as unstable. They may be testing, pre-release, release. And once they've got that far, then they're available for someone to come onto their machine and go upgrade. And that's the package they're going to pull in. So what's the challenges for the attacker? How do I store my malicious payload code as part of the packaging process? How do I execute the commands on a distro build system? And how do I do the above without being noticed? How do I store my malicious payload code? Well, we're a compression library. Why don't we store some compressed files in our repo for testing? And what happens if one of those files is specifically a corrupt archive full of junk data? This file has 3 streams in it. The first and third streams are valid, compressed streams. The middle stream has a correct stream header, block header, index stream, blah, 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 blah. Only the LZMA2 data is corrupt. This file should be decompressed with this single stream only. So now we have a place where we can stick ones and zeros in the repo that everyone assumes is just random data as part of a test archive. But how do I execute my malicious payload code? First thing we do is we update the git ignore. So why are we going to update this git ignore file? Git is the software that's used for committing and moving files in and out of Git repositories. The git ignore file is there as a list of files that should be ignored on the file system when you're taking the files and pushing them to Git repository. By adding this file, build to host M4, which is a build instruction executable, to the git ignore file, it is no longer added to the code public repository as part of the post-build process. And what I mean by that is, once it's packaged and zipped or XZ'd and presented, normally all of the remnants of the build system are committed afterwards. So you have artifacts of everything that's there. By making this one subtle change, that file is no longer pushed out as part of that project. And remember, the system that does this packaging is under Yeartan's control. So what they were able to do was to place a very minor modified version of this legitimate file on the packaging system. Now remember, it doesn't execute on the packaging system. That's just zipping, presenting, passing over to the distribution build system. It's their systems that have to take this in. So if you were to look at any of those archives that were sent across, those zips or XZ files that were sent across, they would contain the malicious version of this file. But the change was so subtle that no one would notice. Now you could ask, why didn't they throw lots of other files? Why didn't they just put all the bad stuff on the system and send it across? And why did they commit these things to Git? Because people would have noticed. The more change, the more difference between what's in that archive file and what's in the Git repo would have raised concerns. Someone would have noticed. So what they needed to do is they needed to make changes, and they need to make them subtly. That really is it. That's the biggest change they made within the file. That one line. This line here actually means this line here. Using some very fancy obscuring techniques of eval this, move this, do that. Actually, that line inside the computer, inside the build system, translates to that. Anyone on the outside would look at this. And that is, there's nothing in there that's greppable. Nothing in there mentions the bad corrupt file. Nothing mentions uncompressing it. This seems like something to do with config make, a path, a prefix, and send off the stuff to whatever. This is the starting point for everything that happens afterwards. This one line. So now you have a tarball that comes from the build system managed by the actor. They then pass that tarball with the malicious script to the build system. The build system runs that file. It has the line to fix and decompress bad corrupt LZMA. What a mind beam fix is, if you were to look at the file, it's junk. But that one command line replaces this with this, and suddenly it's valid XZ compressed archive. Fixes, decompresses. Now we have a shell script. It then executes the shell script, which then decompresses from this file, which then gives us another shell script that extracts encrypted data from that file. It then decrypts it. It then decompresses the decrypted data, and at the very end, we have this file here, which is the payload. This is the main reason for the whole process, is to have this file on the distro build server when it is building XZ Utils. So then, when it's compiled, when I said about linking earlier, where it pulls in all these different files, puts them together into the binary, that's now included. So I've talked about all of this. So what about SSH? What's it got to do with SSH? Good question. It's all in the libraries. So when SSH utilizes the liblzma, which is part of XZ Utils, for compressing and decompressing data transferred during an SSH session. For those not familiar with SSH, it's a secure shell. It's the protocol that's used for connecting to remote Linux servers to type commands in and to have an interactive session with them. It's also used for transferring files and generally sending files back and forth between machines with sysadmins on Linux systems. It has support for this compression standard. So whenever there's an SSH session loaded up, it loads this library just in case there is a need to decompress this style of data for a file transfer. And so as soon as it pulls this library in, that library then loads the payload. Every single time an SSH connection goes to the system, it loads this part and deploys the payload. So that's how they went from exploiting an individual, exploiting a project, exploiting a build process, to exploiting SSH. Just like this. So libsm is loaded during startup, liblzm hooks in resolution, OpenSSL loads, SSHD tries to resolve, that loads, hooks in the and interferes with the points to a symbol at the malicious implementation. What I said about the iFunc earlier on, about introducing that, the ability to go, actually I'm in charge of this. Not this static path, I have an opinion. There's an opinion on the system how this happens. That's important because it allows that hook. say, actually, you know, this main code path, because obviously within the code base, there's an existing code path to handle this. Actually, this binary, which we introduced here, goes, no, I've got this. Intercepts it, processes it, causes the exploit. How to create an SSH authentication backdoor and get caught. .299 seconds. 0.807 seconds. The timing difference between someone trying to SSH into a system, getting permission denied, on a pre-exploit system, exploit system. Someone noticed that timing difference. Right? Andreas Froon, and I may be mispronouncing your name and I apologize, but this gentleman noticed that difference. He was conducting some system benchmarking. He noticed a difference in the SSH performance because imagine this, you're a sysadmin, you're sat there. You're logging into countless machines, typing commands on your keyboard. Any little discrepancy, you know. It's like in your house, if you opened a door and it suddenly started to creak. No one's going to know that, but you know it because you open it 50 times, 10 times a day, whatever it is. You notice these things. So he noticed these things. So as he says, he was doing some micro benchmarking at the time, needing to request a system to reduce noise, saw SSHD processes were using a surprise amount of CPU, they were taking for too long, got suspicious, recalled that I had seen an odd Valgrind complaint, which is a process of just automatically logging into SSH and trying security connections. And a few weeks earlier, I noticed it after some package updates. Really required a lot of coincidences. To go through it again, we went from exploiting an individual, exploiting trust relationships with a project. Exploiting trust relationships with a project. Exploiting the trust relationships between a packaging system and a build system, and then hoping that no one would notice. That's my talk. Thank you very much.
So how do we stop that happening again?
Good question. So the issue around this is that more and more, so one of the things I linked to as part of the news is an initiative, because at the root of all of this was a social engineering attempt. It was social engineering, and the maintainers of projects need to be more vigilant. And also certain projects which are critical or have critical paths, there's an initiative to try and make sure that there's not just one person involved in these projects who can be exploited in that way. The fact that they've come in this way, the fact that we haven't seen others at this stage, I feel that the fact that it took them so long, we're talking 2022 is when this started. They had a path, they knew what they wanted to do, but it took them just over nearly 2 years to exploit that path. Now, some would say one of the reasons why they got caught is because they got sloppy, because of this problem with the speed. But one of the things I couldn't include in time, by the way, there's a huge amount of technical depth behind this, which I just scratched the surface. I mean, the depths they went to obscure what they were doing was immense. Very talented. It's a shame they're putting their talents to that use, but very talented. But they...
But they were state actors then?
That's the idea. The idea is that the belief is that they were state actors and that they had the finances to be able to do this. And so the fact that it's took them that long to get that far within a project, but still not reach the end goal. So the bit I never, again, apologies for cutting off because I ran out of a bit of time doing the slides today, but the bit I never noticed is that at that stage it had been built in build systems. That person had it on their system. But the reason why they had it on a system was because they were running the bleeding edge version of a distro. It had just been put in there out of the distro's build system into they've upgraded into their system because they're constantly testing. They wanted to know if there was any issues with their system or with the software that they were running. And it was at that first stage where it got released, someone saw it. So we're talking days. 2 years to get to that point, days for someone to realize. So in many ways, I feel this is a success of the open source community, because the moment that it was removed from obscurity and released, the community rallied, realized, understood it, and within days we had an open, community-driven sort of post-analysis of what was happening.
But does that also demonstrate that only a human can detect a vulnerability that's created by a human?
No, well, potentially, I think that, I mean, one of the key aspects of this was also the fact that they disabled the security tooling on the particular entry point function. So in terms of robustness and changes, I would say, I don't think you're going to be seeing commits like that going in anytime soon.
But the gatekeeper is always, there's always a human gatekeeper, right? In terms of code checks checked in and codes checked out.
100%. At the moment, human gatekeepers, and over time, there will be automation. No, but the whole point of the open source fuzz project is automation, is to automate these things. And when you said it's a coincidence, right? He had a random chain of events that led him to that conclusion. The point of the open source fuzz project is to generate large amounts of random events to increase the chances of catching such a thing over a period of time.
Right, so you can, effectively, you can simulate coincidence.
See, what I would say is the coincidence that he had was very refined A, B, C. We're talking about infinite monkey
But the
syndrome.
characteristics of coincidence can be created mathematically.
In that narrow pathway, yes.
Yeah, correct.
Yes.
It sounds like the good news was that it wasn't out in the wild very much at all. So most people's exposure should be very limited.
And in terms of the wild, again, it was on pre-stable. These were unstable systems.
So that's great news.
Yeah.
The other thing that strikes me is that if it's a state actor, the whole thing may be a psyop, and basically it doesn't matter whether they, because basically it spreads fear and uncertainty and doubt into the open source movement.
If you mean spread fear, uncertainty, doubt by hardening various open source projects, then.
But clearly,
there are,
I say on one hand, companies who are sort of perhaps not so keen on open source as they might have been, and there's also governments who have their own kind of approved distributions between the two of them.
That's true. I would say in this instance, what's the change? Someone becoming an employee of a company and implementing that subtle change. I don't believe anything we saw here would be different if that person was employed in a company. The only thing that was different was, for me, was the fact that let's say the feedback loop on the release was shorter and wider. Inside a company, it may be an internal QA team. In terms of going from unstable to stable to release to the public, that feedback loop is based on a QA team and other sorts of internal factors. Whereas with these distributions, that feedback loop, in my opinion, is shorter and wider.
So I was going to ask, isn't this not the first time a unpaid maintainer has reached their end of the tether in terms of just how much commitment given to a project, and as things have migrated on, bad things have happened, or they simply haven't had time to do.
There's various examples. It's not just individual maintainers. So there's certain open source security projects that have been, let's say, co-opted by vendors, not by state actors, but by vendors. And the core of the technology has essentially changed, but they have carried over the credentials of the previous architecture into that new release of the technology. It's something that the Cloud Native Computing Foundation has made. It's been a problem, because you do have these companies who early adopters. They've struck gold in terms of being the player at that time. Lots of companies have adopted their technology, but they are, like you say, small, burnt out. Also, that talent doesn't remain hobbyist for long, gets swallowed up with various companies, they get promoted, they don't have time to maintain the projects anymore. A vendor comes in and says, look, we're going to throw 5 people on this. But you know what, we're also going to slightly architect it more in line with our product portfolio and align it to our product portfolio. But we're still going to keep the name, and we're still going to keep all of the credentials, and we're still going to keep the report, our security report, up based on, you know, the previous architecture on our sort of architecture that we've slowly drifted to over time. So it does happen. The other sorts of issues is around squatting. That's a big thing at the moment for projects which, again, are no longer maintained and get removed from various artifact repos. Someone else comes along, takes over that project because it's now redundant, puts their malicious code in, and just sits there waiting for some random software project that links to it to pull it in and compile it.
I was just going to say, so I was out at KubeCon last month. Obviously, this big thing in the CNCF community, lots of conversations about it. A number of points kept coming out from maintainers of projects, though. Number one was owning or maintaining any of these projects is horrifically stressful and can very quickly lead to an immense amount of burnout.
Yeah.
In the nicest possible way, I lost count the amount of times I heard people over that week say, let people come in smoothly, how you can talk to your bosses about understanding the value of what you're doing as part of this project and making it part of your job, not part of your hobby.
Yeah.
The other bit that seemed to keep being talked about was the importance of these very critical pieces of software that are really, really small, really, really unsexy, and to be honest, to a certain extent, hit a point at which they're awesome, they're brilliant, they're wonderful, but do they really need anything more done to them apart from those most corner of corner cases?
Yeah.
Which is a big issue as well. It's part of why, to be honest, the CNCF piece on it's a bit of a pro and con because they have this whole thing of taking projects, getting them through to graduation. As part of graduation, you have to pass security audits that are constantly going on and have a certain amount of people that are regularly committing into the project, and particularly companies that are paying people to commit into these projects.
Yes.
Which is a big important thing, because if someone's doing it as part of their job, they can carry on doing it. If they're doing it because they're bored at home in the evening and then they get a new girlfriend, they're going to stop doing it.
Yeah.
And it's a light-hearted thing to say, but it's factually correct. One of the most important things that kind of struck me coming out of it, though, was any of us that work for large organisations where we see an opportunity for this kind of work and getting people either partly or fully on board to work on these kind of projects as a paid-for job should do it. Because we all use software like this. It's all part of our lives. Even if we don't understand that it is, it is. And we minimise this risk by normalising these things into jobs for people, because they're doing wonderful, valuable work that all of our pay packets are based on.
Well, again, I think you're preaching to the converted here.
Oh, I don't know. Yeah.
So I totally agree.
I just wanted to say it to everyone else.
Oh, okay.
I'd just like to ask if that fellow who discovered it has been given a medal yet, maybe a solid gold tux.
I don't know. Maybe, I don't know if they're American. They may have got half a day off.
He doubled his annual leave.
Yeah, exactly.
Right. I think we're going to have to call it there.
Yep.
So thank you very much to David.
Thank you.